Okay, good morning. Welcome to
SummerMath number 20.
SummerMath number 20. So today we're talking about overcounting again.
Yeah.
And this is our new chapter, but this is all we're doing in the chapter right now because
Yeah.
you guys have camp this week.
Yeah.
We're just talking, right?
Yeah.
So yesterday we tried to arrange the letters of pig, and how many different ways were there to do that?
I think there was 6 ways.
Okay, and how did we figure that out?
Well, you had the 3 slots. 3 times 2 times 1.
Okay. Okay, now, this one, right here, over here. So, okay. How do we do dad? What was the difficulty with rearranging the letters of dad?
These 2 D's are the same.
Those 2 D's are the
So if
same.
you write dad, and if you flip the D's around, it'll be the same case.
Yeah, that's right. If you flip the D's around, it'll be the same case.
So that means you have to divide by, you have the same thing here, except you have to divide by 2.
You have to divide by 2. And why do you have to divide by 2?
Because these 2 D's are the same.
Because the 2 D's are the same. So for any arrangement you have here, pretending they're different,
Yeah.
there's always going to be 2 that are the same as each other.
Yeah.
Because you flip the D. So this was 3 times 2 times 1 divided by 2, which is
3.
3. Very good. Okay, now, you were interested in this word yesterday, right?
Yep.
Why?
Well, it has the double letters.
It has the double letters, okay. So what do you think you're going to do on this one?
Well, you can sort of do the same thing as with dad. Because you can all, when the E's flip, they're the same.
So you think dad is similar to sheep?
Yeah.
Dad is similar to sheep?
When it,
What?
if these 2 weren't the same, it would just be 5 factorial.
Okay, if these letters were different, we would have 5 factorial. Okay? But they're the same, so what do we have to do?
Well, we have to divide it by 2.
We have to divide by 2. Okay, because you could pretend they're different and write down all the different 5 factorial arrangements, and you would find that for no matter what the arrangement was, there would always be a pair that had the E's flipped. So you've counted all of the pairs twice.
This is going to be 60.
So you got to divide by 2, so it's 160.
No,
Oh, I'm sorry.
there's
It's
60.
120 divided by 2, which is sometimes known as 60.
60.
Okay, now, you ready for the ultra challenge?
Yep.
Dun 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 dun! MISSISSIPPI. Mississippi.
What?
What?
This time, you have 2 sets of repeating letters.
No, 3 sets.
You have 3 sets of repeating letters.
Yeah. What?
What?
This
Okay.
is crazy.
This is a crazy one. We want to find all the different ways we could rearrange those letters.
I think this would be maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factorial if all the letters were different.
Okay, so if all the letters were different, we'd have 11 factorial, right?
This is a big number. Except you have to divide.
By 4,
Well, let's see. Let's see what we have to divide by first, okay?
Yeah.
We have how many S's?
we have 4 S's,
4 S's.
4 I's, and 2 P's.
Okay, what do you think is the easiest one of those to deal with first?
The 2.
Okay. So how did we said, pretending these P's were different,
Yeah.
how many times did we count the pairs of P's?
We counted.
It's 11 factorial different ways. Because the P's that still have to be in there.
Right, so each arrangement, how many different times did we count? Pretending they're different, right?
Yeah.
How many times did we count them?
We counted them twice.
Counted them twice. Okay, so we have to divide this by 2 for that. Now I want you to see U right here. So U, lock. Now we have a challenge. We have the eyes. We have 4 eyes. Okay? How, if we pretend those are different, how many ways can those eyes be, these 4 eyes be rearranged in every arrangement if they're different?
Well, 24.
24 or?
4 factorial.
Or 4 factorial. Notice 2 is the same as 2 factorial. So these eyes are going to be arranged in 4 factorial ways in every arrangement. So what do we have to divide by to get rid of that?
4 factorial.
What do we have to divide by to get rid of this overcounting?
Well, 24.
4?
4 factorial.
4 factorial. Okay, now, unlock, open the S's.
It's the same thing.
It's the same thing. Okay, so the S's, if we pretended they were all different, they could be arranged in 4 factorial ways. So now we have 11 factorial divided by 2 factorial, 4 factorial, 4 factorial. And whatever that number is, that's the number of ways to rearrange the letters of Mississippi.
Big number.
Big number.
Yeah.
Now there's one surprising thing in this that I should mention.
Yeah.
How do I know that's an integer?
Well,
And how do I know 11 factorial can be divided by 2, 24, and 24 all at the same time?
Well, 11 factorial for the 2, you can just take out a 2 factorial from that.
Yep, you can. But now you can't take out the 4 factorial. You got to find it somewhere else.
yeah, but there's a 6 and a 4 in there.
There is a 6 and a 4. Okay, so 11, 10, 9, 8, 7, 6, 5, 4, 3, 2 over 2 times 24 times 24. So you said take out the 2 there.
Yeah.
And you've got a 4 and a 6.
You got a 6 and a 4 that cancels that 24.
And you can cancel the other 24 with this 3 and the 8.
And the 3 and the 8. Okay, so it turns out it is an integer. It's all this. It's 11 times 10 times 9 times 7 times 5 divided by 1. So that's an integer.
Yep.
Okay? But it's not obviously an integer when you look at it for the first time, right? It might not be. And it's got to be an integer though. Why?
Well, because
You can have like 24 and 1/2 arrangements to it.
Right, we're counting arrangements of this. You can't have 24 and a half arrangements of letters,
Yeah.
right? So this has to be an integer.
Yeah.
So if we got a number that wasn't an integer, like 24 and a half,
we did something
we
wrong.
did something wrong. Okay, hey, good job this morning, guys. Good job.